Students, some of the result of doodling is shown on the board. These drawings are called curves. Let's understand simple curve. A curve that do not cross itself is called a simple curve. Out of these four curves, first, second and third are simple curves. And fourth is not a simple curve because it is crossing itself. Simple curves are of two types, open curves and closed curves. Open curves are the curves which do not end where they start. For example, curve of a bridge is a perfect example of an open curve. Then we have closed curves. Closed curves are the curves which end where they start. For example, curves of orbiting planets. Orbits of the planet end where they start. Now, let's see what is polygon.
John and Alice, can you observe the patterns on the floor? These patterns are made of polygons.
Polygons?
What are they?
A polygon is a simple closed figure made up of only line segments. Some polygons you already know are a triangle and a square. You can see that the floor designs are made up of quadrilaterals and octagons.
What is an octagon?
The octagon belongs to the family of polygons. It is a simple closed figure made up of 8 line segments. Come, let's learn more about polygons. First, we will learn how to classify polygons. So, how many varieties of polygons can we think of? Many. Can we say? Yes. Let's see how we can visualize different polygons. Let's start with a simple polygon, a triangle. A triangle has 3 sides and thus is a 3-sided polygon. If we cut the triangle at one vertex and add a side, it will become a 4-sided polygon, which is called a quadrilateral. Again, if we cut the quadrilateral at one vertex and add another side, it is a polygon of 5 sides, which is generally called a pentagon. In this manner, we can obtain a 6-sided polygon, a hexagon, a 7-sided polygon called a heptagon, and so on. If we have an n-sided polygon, it is called an n-gon. Take a look at the table to understand the classification of polygons according to the number of sides or vertices. Let us now learn what a diagonal of a polygon means. We know that each side of a polygon is connected by 2 consecutive vertices of the polygon. Now, we take 2 non-consecutive sides of a polygon and try to connect them. Let us consider vertex P. The consecutive vertices are Q and T. The rest of the vertices R and S are non-consecutive vertices. We connect the vertices P, R and P, S. These line segments are called diagonals. Therefore, we can conclude that a diagonal is a line segment that connects the non-consecutive vertices of a polygon. Alice and John, can you show the other diagonals of this polygon?
from vertex T to vertex Q and vertex R.
From vertex Q to vertex S and then to vertex T.
The diagonal from T and Q is already drawn. So, it is considered as a diagonal from Q to T. So we can conclude that a line drawn connecting two non-consecutive vertices of a polygon is called a diagonal. So, a diagonal in a polygon is drawn connecting two non-consecutive vertices. Now, let's look at this figure. It is a polygon in all respects. John, can you draw the diagonals for this polygon?
Here they are. But how to draw a diagonal between these non-consecutive vertices S and P?
It seems that the diagonal drawn between these points lie outside the figure. That's a good observation, John.
If a diagonal lies outside a polygon, then the polygon is called a concave polygon.
If all the diagonals lie inside the polygon, then the polygon is said to be a convex polygon.
Can we see some examples of convex and concave polygons?
Oh yes, definitely. Look at this polygon. How can we verify if this polygon is convex or concave? Let's start by drawing diagonals from vertex A to the non-consecutive vertices C, D, E, F and G. Similarly, we draw diagonals from vertex B to other non-consecutive vertices. Now, we draw diagonals from vertex E to other non-consecutive vertices G and H. Likewise, we draw diagonals from vertex F to other non-consecutive vertices. Now, observe that diagonals EG and FD lie outside the polygon. Therefore, this is a concave polygon. Now we will see 4 polygons. John and Alice, here are 4 polygons. Name them and identify if they are concave or convex polygons. Alice, you first.
The first polygon has 5 sides. So, this is a pentagon. Now, on drawing the diagonals, we see that all lie inside the polygon. Thus, it is a convex polygon.
Now, it's your turn, John.
This polygon has 5 sides. So, this is a pentagon. To check whether this polygon is convex or concave, I will draw the diagonals. One diagonal lies outside the polygon. So, this is a concave polygon.
The next polygon has 6 sides. So, this is a hexagon. Since 2 diagonals of this polygon are lying outside the figure, this hexagon is a concave polygon.
The fourth polygon is an octagon since it has 8 sides. All the diagonals lie inside the polygon. Therefore, this is a convex polygon.
Thus, 2 polygons are classified as convex and the other 2 as concave based on the position of their diagonals. Now let's differentiate between 2 polygons that have the same number of sides, based on the length of the sides and the measure of its angles. We have 2 polygons here. Alice, can you tell the difference between the polygons?
The number of sides is the same for both the polygons. However, it seems that the first polygon is quite different from the second.
How are they different, Alice?
Look at this polygon. Each side of the polygon is of the same length. Also, the measure of each angle is equal. On the other hand, in the first polygon, the lengths of the sides and the measure of the angles vary from each other.
Oh yes! Then how can we name these two polygons?
That's a good question, John. The polygon with equal sides and equal angles is called a regular polygon. The polygon with unequal sides and unequal angles is called an irregular polygon. To conclude, a regular polygon is equiangular and equilateral. If a polygon satisfies these two conditions, then it is said to be a regular polygon.
How do the words equiangular and equilateral connect to a regular polygon?
Okay. The word equiangular means the interior angles of the polygon are equal to one another. The word equilateral means the lengths of the sides are equal to one another. If a polygon needs to be called a regular polygon, then it should satisfy these two conditions. For example, take a rectangle. Here, the interior angles are equiangular, but the sides are not equal to each other. Therefore, it is an irregular polygon. Whereas, a square with all sides and angles equal is a regular polygon. Now we will learn about the sum of the interior angles of a polygon. When we say interior of a polygon, we are talking about the region that is bounded by its sides. Each interior angle of a polygon is the angle made by two consecutive sides. Here, we will find the sum of all interior angles of a polygon. This is called the angle sum. To start with, we will find the sum of the interior angle of a triangle. Alice, can you tell us the sum?
Yes, it's 180 degrees.
Good, Alice. Now, John, look at this square. Can you tell us the sum of the interior angles of this square?
It's 360 degrees.
Good. Now, if we consider a polygon like a heptagon, finding the sum of the interior angles needs a formula. The angle sum of a polygon is given by n minus 2 multiplied by 180 degrees, where n stands for the number of sides of the polygon. Let's verify the formula for the triangle. It consists of 3 sides. Therefore, n is equal to 3. Therefore, the angle sum of a triangle is equal to 180 degrees. If we consider the heptagon, the angle sum is 900 degrees. So far, we have discussed interior angles. For any polygon, we have the concept of exterior angles also. Further, we will find the sum of the exterior angles of a polygon. Now we will discuss the sum of the exterior angles of a polygon. Let's see what an exterior angle is. Let's take a pentagon. At one vertex, we extend a side. This side makes an angle with its consecutive side. This angle is called the exterior angle. Here you can observe one property, Alice and John. Can you tell us what?
Here, the interior angle and the exterior angle seem like adjacent angles. These angles form a linear pair.
The sum of adjacent angles on a line is 180 degrees.
Exactly. If we know the interior angle, then we can find the corresponding exterior angle, and vice versa. Let's draw the exterior angles at all vertices. If we add all the exterior angles, the sum is 360 degrees. If we consider other polygons, such as a hexagon or an octagon, the sum of the exterior angles is 360 degrees.
Is it applicable to other types of polygons too?
This is applicable to every regular and irregular polygon, irrespective of the number of sides. We can conclude as follows. The sum of the exterior angles of any polygon is 360 degrees. So, Alice and John, this completes our short discussion on polygons. You have reached the end of this section. Before moving on to the next section, let's recap the key points covered. In this lesson, you have learned to classify polygons based on the number of their sides or vertices. You have also learned to differentiate between regular and irregular polygons, as well as between convex and concave polygons. In addition, you have learned to calculate the sum of the interior angles and the exterior angles of a polygon. Hope you enjoyed this learning experience. Find the angle sum of a regular hexagon and an irregular hexagon using the angle sum formula. We are given two polygons. We have to find the angle sum using the angle sum formula. As we know, the angle sum of a polygon depends on the number of sides and not on the length of the sides. Therefore, the angle sum of a regular hexagon or an irregular hexagon is the same. The angle sum of a polygon is given by the formula n-2 multiplied by 180 degrees, where n stands for the number of sides of the polygon. First, we will find the angle sum of the regular hexagon. A hexagon has 6 sides. Therefore, n is equal to 6. We will substitute the value of n in the angle formula. On simplifying, we get 720 degrees. Therefore, the angle sum of a regular or an irregular hexagon is 720 degrees. Find the interior angle x of the irregular pentagon shown. To find the value of x, we'll first find the angle sum of the pentagon. We know that the angle sum of a polygon is given by the formula n-2 multiplied by 180 degrees, where n stands for the number of sides of the polygon. The pentagon has 5 sides. Therefore, we will substitute n as 5 in the formula. This implies that the angle sum of the pentagon is 540 degrees. The sum of the interior angles of the pentagon in the figure is as shown. We will use this angle sum to find the unknown angle in the pentagon by equating it to the sum of the interior angles. On equating, we get. Therefore, we get the value of the unknown angle as 140 degrees. Find the measure of the exterior angle, x degrees, in the given figure. We are given the exterior angles of a triangle. One of the 3 angles, x, is unknown. We need to find the measure of x using the other 2 known angles, 90 degrees and 135 degrees. We use the fact that the sum of the exterior angles of any polygon is 360 degrees. the exterior angles of the triangle are 135 degrees, 90 degrees, and x degrees. Therefore, the sum of the exterior angles in the given triangle is as shown. We will equate the two equations to obtain the unknown angle x. We will rearrange and solve the equation to obtain the value of x. Therefore, the value of the unknown angle x is 135 degrees. If each interior angle of a regular polygon is 60 degrees, then find the number of sides of the polygon and name it. We are given a polygon with each interior angle of measure 60 degrees. We have to find the number of sides. To solve this problem, we will derive some properties of a polygon. If a polygon has n sides, the polygon will have n vertices and n interior angles. For example, for a pentagon, we have 5 vertices, 5 interior angles. To find the number of sides of a polygon, we will use the angle sum formula. The sum of the interior angles of a polygon is n into 60 degrees. A polygon having n sides has n angles. Therefore, the sum of the interior angles of a polygon is n multiplied by 60 degrees. We will equate both the equations to obtain n. We will rearrange and solve the equation for n. By rearranging the terms in the equation, we get, taking n common in the equation, we obtain the value of n as 3. A figure with 3 sides is a triangle.